Hello, everyone. Can you all hear me? Is the microphone working? Yeah, perfect, perfect. So I was, before I started, when I met Oliver in preparation for the talk, I was getting a bit worried that I was going to be just me and the people picking up the equipment, because it's like the last talk of the last day. Basically, the last the obstacle between you and the pub or you and the tube. So I'm glad that you're here, and I'm glad that you decided to avoid the rain for 1 hour, an hour and a bit more, and spend it with me talking about data science and analytics and some practical viewpoints that I have. So if you're using social media, I encourage you a lot to go use those hashtags. On the one hand, that captures Open Data Science conference things. And if you use the second one, it gives me an opportunity to find what you were talking about, any pictures of me so that I can show my niece how fantastic I was. And just to establish a conversation that way. But I would like to start with a bit of a warning. In the last 4 days, for those of you that had the opportunity to purchase the gold and diamond entries, and for those of us that didn't in the last 2 days, you may have heard a fantastic bunch of people talking about great things and discoveries and advancements in data science and analytics, and the best and the best. And some of the sessions have been quite hands-on and showing you lots of code that it was scrolled, and then just a picture was shown. My talk doesn't even have code. It's totally not technical. It's supposed to be more of a conversation between you and me and among ourselves. I would like this to be a bit more of a interactive session, if you will. So I will direct some of the questions and some of the things that we're going to discuss. And indeed, I will talk to you about some of my viewpoints as to what data science is currently doing, where we're heading, and what the outcome that business expects from us. But surely you're here for a reason. You're here because you want to learn more. You're probably already a data scientist, or you're already thinking about the next step. So yeah, bear with me. It's not a technical presentation. It's more of a conversation. So just to give me an idea of where we're at, can you raise your hand if you are a student or a recent PhD student thinking of going into data science? Okay, great. What about if you are a data scientist already? And if you are a senior data scientist? Okay, maybe I'll raise my hand. Any managers, anyone that needs to deal with data scientists and don't know where to start? Yeah, you are my audience, guys. Thanks. No, I mean, the talk is more of an overview. It's geared for those of us that are new to the area, but also may provide some hints as to what to look for as we go along. So in today's session, we're going to cover some of these things. Or actually, I'm starting with a negative statement. We will not be covering everything data science, although data science is the big title of the talk. We're not going to be covering everything. For that, you may have seen the variety of topics that people were covering the last 4 days. In this case, as I mentioned, this is not technical, but we're going to cover some general aspects of what it is to work with data and to work in the field. And finally, we'll have some discussion points. Hopefully, though some of them will be useful to all. So again, don't expect loads of code. This is the most code you will see, XKCD, and a horrible installation script that hopefully you will never have to run. So for my agenda for today is as follows. We're going to talk about data science. We're going to provide you with a working definition, given that as a field is not that well established. So you ask 3 data scientists what data science is, and you will have 10 definitions. We're going to talk about some skills and competencies and other bits and bobs that people expect from us. We'll talk about data science workflow and how it fits into different areas as you move from creation of a model all the way through to production, and some challenges and opportunities for all of us. So, as I said, I would like this to be more of a discussion between us. So I would like you to turn to the person next to you, either right or left. Introduce yourselves. I'm sure that the coffee breaks have been fantastic, but clicks happen, and you probably only said hello to your friends. So turn around to the person next to you and try to answer some of these questions. You've got about 5 minutes. And I would like to hear the chat that people use to do when you do that. So go ahead. It's a workshop, remember? If you're just arriving, we're discussing these questions among our peers, so turn to the person next to you and discuss those questions, please. Cool. I hope that sort of broke a little bit about the ice a little bit. It gave you an opportunity to talk to the person next to you. If you didn't make use of the coffee breaks for that, make sure that you take each other's names and email addresses and you talk about data science well after this conference finishes. We're going to cover some of these questions as we go along. And with that in mind, I would like to move to the first one. Would anyone like to share with us what you're here? And what were you expecting? Maybe I'll ask someone to share their views. Someone asked me just before, how come that's the introduction to data science is the last session on the last day? I don't know. So the expectations were maybe I would be introduced to data science at the beginning, and that wasn't the case. Is there anything you would like to share about those thoughts?
Sorry, what are you expecting?
Yeah.
I'm a big data, I'm a master's student in big data analytics. And
Yeah. Okay.
And machine learning. So I see there's a lot in common between data science and big data analytics. So I'm here to know what's the difference.
Okay, that's good. So we're going to cover some of that. And for those of us that are confused about terminology, I'll try to give you my perspective on that. Anyone else would like to introduce themselves? Tell us what you're here and what brings you to ODCS. Yes, please.
20 years as a project manager, business analyst in companies like Credit Suisse, Accenture. In the last 5 to 6 years, I've pivoted into data science, like this lady here. I'm doing a part-time master's at Viewpoint, University of London.
Cool.
And I want to hear from practitioners so I can build on my existing knowledge from education and my business knowledge that I've already in my startup.
Yeah, sure.
Pick up best practice and how to do it.
Yeah, no, that's good. That's good to hear. And also, it goes without saying, and we'll probably touch on that. That the role of a data scientist is one that it's ever evolving, right? So we are always trying to learn. I always joke that I'm not going to retire having learned Fortran, right? I learned Fortran, I'm done, Maybe I could, there's still quite a lot of Fortran or COBOL code that needs to be maintained. But, every time you come to some of these conferences, there's something new to learn. Anyone else? Just a final one? This side of the room? Yes, go on.
Yeah, so I come from analytics, advanced analytics background.
Yep.
For consultancies like IBM and EY. Moved on to the data science in the last few years. So I have worked in the data science industry. So for me, I wanted to gather some more insights into the challenges which other companies face, because we face a lot of different challenges, and kind of to gather new insight from what other companies are doing.
Sure. So just to manage some of the expectations there, I'm not going to be covering a lot of my challenges in that. It's more general challenges for us as data scientists rather than the business side of things. But we can continue discussing some of that. Cool. So it's only fair that I tell you something about me. You heard me being introduced. I'm Jesus Rogel. I go by Jay, given that my name is funny to pronounce and people just call me Jesus and I feel like blessing them. So never mind. So I'm a physicist by background. I studied physics in Mexico, and then I went to Imperial College to study my PhD. And ever since then, I started using quite a lot of data. So my PhD was quite a lot of computational work and making sense out of the data that we were generating. So back then, the term data science did not even exist. People never talked about it. And it's even funny that the first time that I had the title scientist was when I left academia. Before it was like a lecturer or, senior researcher or PI or whatever, but never scientist until I left. So I've been working in academia for a number of years at Imperial and the University of Hertfordshire, but then I've been morphed into doing work, analytical work and data science work for companies such as Dow Jones, Prudential, IBM, and more recently AKQA. So it's not Aqua. The founder gets really angry when people call it Aqua. It's AKQA. And we are a digital agency. And as it was mentioned, I'm the author of a couple of books, Data Science Analytics with Python and Essential MATLAB. And I know for a fact that the guys in Berbeck use my book, which is great news for me, of course. So sometimes people ask me, what do you do, right? And I still say I'm a physicist because that's the way that I approach my work and the world, and people just go like, oh my God, so you must be doing string theory, because that's the only thing that people think of when they do physics. Or back in the day, it was like, nuclear physics, and you think, nah, I don't do that. So no, I don't do, this sort of work. I did quantum mechanics. That's my main subject, and, teleportation, and people just go, wow, Star Trek, that's what you do. And, I wish I was fighting the overlords of the evil empires doing that, but that's not what I do. So I have to then say, no, it's not that. I was doing sort of laser physics, sort of interaction of laser with matter and all the rest of that, and people just go, wow, lightsabers, right? Oh, God, no, it's more sort of like, and then you go into a ramble about, the equations and things that you do, and people just, get the a bit of, glazed over in the eyes, and then just ask you to leave or go for some coffee. So at some point, I started saying that I do some modeling, but this was a bit of a problem as well, because people imagined that I was doing this sort of thing, right? It's like, look at me, compare that with that. No, not that sort of modeling. My sort of modeling is like this. That is me in the Nevada desert taking a call from a client whose model just collapsed, and I was just there. So a colleague of mine took that, and that's my sort of modeling. You can see, the catwalk type thing. And of course, sometimes you get some cool stuff also as a data scientist. These are some shoes that I got made from Nike when we were working with them. And yes, it does say data science there. That's the sort of geekdom that I do. But more appropriately, the modeling that I do was these sort of things, right? So these are some simulations of a laser beam moving through some medium and then having an object that served as an obstacle to the light, and these particular sort of beams heal themselves. And we wanted to understand how that healing was happening. And for that, we generated quite a lot of data, both from the lab and from the simulations. And this is the way that I ended up doing data science. So I would like to ask you now this. What comes to your mind when someone talks about data science, and how do you define it? Anyone would like to share their thoughts? And bear in mind, if this had been the first session, you would have an excuse. But this is the last session, and you've heard lots of things about data science, so you surely now have a view on what data science is, right? Anyone? Ooh, silence. The longer it takes for you to speak, the longer this is going to take, the longer you're going to get to the pub, the longer you're going to get home. Come on, someone.
What about something like the use of data to build models to predict or classify and improve outcomes?
Okay, so some keywords there: data, prediction, models, yeah.
Improve outcomes, as in whether they're clinical or business.
Okay.
Clinical patient leaves hospital earlier, business, they say yes to my marketing more often.
Cool. Anyone else? Yes, over there.
I'm just thinking what a nasty job title, really.
It's nasty job title, and yeah, that's true, right? I mean, a few years back, I can't remember the exact date, but the MIT review came up with this article saying that data science was the sexiest job of the 21st century, and I was just thinking that I made it. That's it. Now I can do modeling. And the reality of things is that we've been doing data science by any other name, right? So if I had arrived to a dinner party at some point, 10, 15 years back, and I said I was a physicist or I'm a mathematician or a statistician, people would just go like, oh, God, no, goodbye. But now you say I'm a data scientist, and then people go like, ooh, cool, what sort of data you use, and what the industry, and all the rest of that. Isn't it fantastic? And yeah, it changes. The problem sometimes is that either when you mention data science, this comes to people's minds, that it's lots of scribbles there that have nothing to do with data science, because there's some bits there that you would never use, but it's sort of magic and maths and all the rest of that. So who would have thought that doing some probability these days was the thing to do? And the reality of things is that the world is becoming quantified, and it is the case that companies that are winning companies are data companies. Inevitable that they would like to improve on that, and who could blame you if you've got some data that is sequestered and is doing nothing for you, and then someone comes and tells you, well, there is, and I hate the term, but it's been mentioned so many times, that all actionable insights about what I could do with my data, and you just think, oh, kill me now. But okay, I'll give you some actionable insights. Why not? The problem is that sometimes people come and say, oh, I've got this data set. Could you tell me something I don't know? And then I start going into Dick Cheney style soliloquy, where I go, well, I don't know what you know, and I don't know what you don't know, because you don't know what you don't know, and there are many unknowns, and why don't we start with a question, right? Why don't you tell me what it is that you would like to achieve, and then we can assess whether the data is suitable for what you'd like to do, rather than, oh, I've got this data, use some fancy model just for the sake of it. I'm a firm believer that, and I'll show you a quote that I really like later on, that you could answer some of those questions even using simple statistics and even counting. You don't need to use immediately the latest and greatest in deep learning and XGBoost and all the rest of that, because sometimes it's not needed. And when you do it, then you realize that it's difficult to put it into production. So you have to have the appropriate things there. So this is my working definition for the objective of data science. I don't want to even define it itself. I would like to define the objective of it. So for me, the aim of data science is to help customer-focused organizations to accelerate the impact of their data and their customers and their business. Notice that I don't use the word model. I don't want to use prediction, and I don't want to use data other than in data science, right? That's not to say that those things are not important, but sometimes we need to go back as to what data science is doing. Data science, for me, it's not the star, it's the ancillary part of the business side of things. And notice that I'm talking quite a lot about business, not so much about traditional research, because in traditional research, the stakeholders are a little bit different. So I'm talking about doing impact on business decisions. Whether you do that with a model and do predictions, that's fine. But sometimes I have found companies who would like to be there, but they are not ready yet, right? So you need to start with even some, ways of understanding what has happened in their past so that they could pave their own future, right? So I was mentioning that data science is nothing new, and I would like to show you some history. Give me just 1 second. I need to change bits and bobs. And then I'll do this and that. And here you go. Oh, not yet. There. So if you ask some of my Greek friends, everything started in Greece. So I should start there as well. So Thales of Miletus was the first data scientist. He was a businessman who had olive oil, and he wanted to account for some of that stuff. So we know Thales for philosophy, but he also was doing quite a lot of administration of his own fields, and he had tables of how much production of olive oil was being generated, and how much he was selling, and who he was selling these things to. So he was using the best of the information that he had to make decisions in his own business, and that starts fine. Let's move on a few years into the future, 1654, origins of probability. I'm sure you all have heard of Girolamo Cardano or Pierre de Fermat started thinking about games of chance and the dice. What was the chance of getting some of that stuff? And we all are interested in these sort of things, right? We can mark the bit of statistics, so a lot of the things that we do would not be possible without that. So John Grant, the natural and political observations made upon the bills of mortality. So basically he was interested to know what was the likelihood of someone to live a certain amount of time so that they could pay off life policy, effectively life insurance, right? So who would have thought, 1662. Of course, without calculus, we wouldn't be here with doing some, fancy neural nets. So it's either Leibniz or versus Newton and Newton, depends how you count that. I leave it open to you in the 1665, 75. Who would not have used Bayes' theorem in some of the things that you do that dates back from 1763. So a lot of the techniques that we are using are not new, right? Some of that is background that we have covered in quite a lot of time, right? Bayes' theorem wasn't even published by Bayes himself. It was published after he died by his friend Richard Price. And there you go. So who would have thought you can become famous after you die? Make sure that doesn't happen to you, but there's many other things we could have a look at. Analytical engine in 1837. Of course, Ada Lovelace and the first computer program in the 1840s. Gradient descent dates back to 1847. So when someone uses that to optimize, we're using techniques that really are quite old, right? Boolean algebra. I'm sure that your programs would not be the same without an XOR or an OR if you didn't have them there. Graphical representation of things, we can go back to 1855 and Florence Nightingale for some of the coxcombs. So data visualization has been with us even before Tableau, right? I mean, a lot of us used to think, ooh, Tableau. Well, ask Florence Nightingale. She didn't even have that. She had, pencil and paper for doing some of that stuff. Of course, regression is the workhorse of machine learning. And that was first proposed, first shown in 1886 with Francis Galton, regression towards mediocrity in hereditary stature. So he was interested to know if you have a child, what's the likelihood of that child being taller or shorter than you? And he would call that mean, as we would call it these days, he would call it mediocrity. So it was mediocrity in that sense, not as we think about it these days. So that title would probably not be passing peer review these days, right? So it's like, well, maybe you should be a bit more politically correct, but never mind. Of course, we've heard of Alan Turing and Turing machines. So, I need to say nothing more about him. And the list goes on. The Colossus at Bletchley Park, the birth of cybernetics in 1948, the first model in 1949. And as you can see, some of these things start getting closer and closer together in time as we start going through them, right? So the gaps at the beginning of this little history that I'm presenting you were big chunks of time. But as we go along, you can see that this is, even in the same year, you have some algorithms and some important developments, Unix. Who doesn't love Unix, right? Other programming languages like Pascal, the birth of the microprocessor in the 1970s, and so on and so forth. So I like this one. Data science, people think that it was born like yesterday, but the first time that was proposed was in 1974, so he's a little bit older than me. And Peter Noor disliked the term computer science. He thought that computer science should not be called computer science, like what the hell is that? We should call that datology or data science. So data scientists have been in existence one way or another since the 70s, but never as sexy as now, right? Backpropagation was also invented in 1974. Let's move on, a couple of things. This is a very important book for data science, Exploratory Data Science by Tukey. He argued more emphasis would be needed in placing on the use of data and suggest hypothesis to test. So the questions I was talking to you about, starting with the hypothesis, starting with the question, and then use the data for that purpose rather than the other way around, the typical way that stats is presented. I mean, I'll think back of your courses on statistics, and typically those start with, okay, here's a bunch of numbers, here's how you calculate the mean, here's how you calculate the standard deviation, and some probabilities, but it's very rare that some courses start with what is the questions that we would like to start to answer, and here are some techniques to approach them, right? So it's no surprise that a lot of us start learning stats and then just get disheartened with it because it's difficult to see some of that usage of them. Let's move on. Now, the support vector machines, early 80s, late 70s, and now everyone just goes like, ooh, I've got some SVMs, right? Let me go quickly to the 2000s. So the World Wide Web 1990s, Linux kernel. This one, I'm sure that, raise your hand who uses Python. There you go. It's not even that old, 1991, right? And it started as a success, as a project, personal project that Guido von Rossum started on a Christmas break. And who would have thought that now we're using it and giving courses and writing books on them, right? R, how many R programs we have here? It's even newer than that, 1993. Its predecessor, the S programming language, had been there before, but and now S does not even exist anymore. I like this one, 1997. Jeff Wu, during his inaugural lecture, proposed that the statisticians should be rebranded as data scientists, sort of following up from that 1974 paper. But this started some of the newer trend into what data science would become. Let me go, as I said, to the 2000s. macOS and Windows XP released. That's great, This one, 2001. Unlike physics, unlike chemistry, unlike economics, it's not a field that has been well established. I mean, it's quite new, although a lot of the techniques, as we have seen, have been there for a long time. But it started becoming a a topic on its own right, academically speaking, around 2001, when the first journal on data science, the Data Science plan for a journal by William Cleveland, started up. And that was the first journal for academic papers on data science. It was not economics, it was not computer science, it was like the combination of those things. And it started becoming a thing on its own right, to the point that these days we even have masters on data science and even PhDs. I mean, in my day, you could never think of doing a PhD in that. So again, 2003, Columbia University started up an institute for data science. It was not, it's becoming a discipline in its own right, and it's here to stay. Finally, the journal was out in 2003, and they put in their scope almost everything that has something to do with data, yet the most important part is that it has to be applied. Hadoop in 2005, AWS 2006. Did you know? Were you aware that only in 2006 AWS was in existence? Prior to that, what did we use? Our hands, I guess, you know. The CUDA GPU is 2007, so it's like yesterday, right? Watson wins Jeopardy, 2010. Siri becomes a thing in 2011. Deep learning breakthroughs by Hinton and Ng from Google in 2012. So literally, yes, like, you know, the day before yesterday. TensorFlow was, outed to the world in 2015. And how many of you use TensorFlow? There you go. What were you doing before 2015? There you go. Of course, in 2017, my book was published. It's a very important point in the history of data science. And of course, you're here in 2018. So it's nothing new, but it's an agglomeration of some of those things. Now, what I would like to argue is that a lot of the things that we have been asked to do is, on the one hand, some really old techniques that we need to apply with new technology, with new hardware. But also, it's very broad. It's from calculus all the way to probability and then even technology. So sometimes it's hard to find what data science for us means. And for that, I will continue the presentation here. Give me just 1 second. So it's a matter of perception, right? So what is data science? Well, it depends what it is that you require it to be doing for you. For some of us, it's very technical, and it's more towards the data engineering side of things. For a few of us, it's more managerial, and we need to manage a team of data scientists to achieve certain things, and then the spectrum in between, right? It's not just one simple thing. So another way of thinking of this is that data science is the use of data and its metrics to drive and inform business decisions. We employ data science and engineering to enhance product performance, and that's super important. That picture of the jackalope will make more sense later on, but remember that one, that's my allegory for what a data scientist should be. So what about the other terms? Someone was saying, well, I've heard about, big data and data science and statistics and machine learning and all the rest of that. So, well, let's just condense some of that stuff. Let's consider only the computer science side of things. People sometimes use the machine learning term and artificial intelligence and data science interchangeably. And raise your hands if you think they are the same thing. Of course, you are well known. You have good knowledge of these things. So, what's the difference? If you don't agree that that's the same thing, what is the difference between machine learning and artificial intelligence?
It's probably the action part. So, machine learning is a machine can learn.
Yeah.
If you can, but it doesn't know how to react to certain situations. It has learned, and I feel that's the last bit which you have to figure out.
Okay. So if you learn something, you're not intelligent. That's what you're sort of saying.
You learn something, you're intelligent, but you're not reactive.
Okay. Anyone else? Yes.
So machine learning can be one way to reach AI, but it's not the only way. So Bostrom talks about in superintelligence how you could slice a brain and scan it and try to recreate it. And that way you don't have to use machine learning.
Yeah. Okay. That's now we're going Frankenstein, but why not? Anyone else?
I think some of what you were saying is maybe semantics, because machine learning to me is about you have data and you can derive insight for that, and I know you don't like that word, but you can, derive insight and it can tell you to do something or class something or predict something, whereas artificial intelligence is maybe the next step whereby the algorithms or neural networks that you have built can then go on to build or do something without you. So it's that thing about, right, here's an algorithm, here's some data, and whether your answer's terrible or brilliant, there's an outcome or classification or prediction. With the neural networks, you built something, and it might be able to infer or add on or change the neural net itself. So it's almost like acting upon itself.
So having feedback. Fine, yeah, so I don't think we're going to come up with a consensus. Yes?
I think machine learning is what we call it, and AI is what they call it.
Yeah, probably. Yeah, that's a good one. So I don't think we're going to come up with a consensus as to what the differences are. For me, the field of artificial intelligence it goes beyond computer science, right? It's even philosophy. What does it mean to be intelligent, and therefore that something artificial is intelligent? What does it mean to be creative? What does it mean to be self-aware? Some of the things you were talking about in terms of being reactive. So I can still build something that if it senses with a temperature sensor that it's hot, it will react like this. I can do that. It doesn't mean that it's doing that intelligently, right? So it's probably beyond some of that stuff. But for the computer science side of things, is intelligence displayed with machines, and perhaps using that reaction type of thing. And indeed, as was mentioned before, machine learning is a way of achieving that artificial intelligence, but it's more sort of a subset of the things that you could do with it. And in that case, machine learning is more about trying to find patterns in the data that then that machine can learn. And those things can be done with a variety of things. It could be, even an if statement could be a way of finding some of that stuff. I'm not saying that, that's not the case, but, when you first start learning some machine learning algorithms, the first thing that you do is regression. And a few of us, and I'm sure that you may deny it, but a few of us just go like, what? Regression? But that's like, GCSE. How is that machine learning, Indeed, one way of doing that is deep learning. So, using those neural nets as a way of finding patterns so that we can call it AI. But, that a company says, I'm going to have my AI doing X. You just think, well, never mind, right? So,
isn't that wrong to use regression and not the purest definition of machine learning? Regression machine learning when it is not. And a lot of people do it. So is that a good practice, or does that really happen? Do you see that a lot of people are using that term?
Yeah, sure. Whether you like it or not, a lot of the background that you require for a lot of other models is encompassed by regression. So you start learning about the way of penalizing the regression. You start learning about what the data means, whether you are overfitting or underfitting. And if you are a newcomer, if you know nothing about it, it's a good way to start. So I'm putting down my hat as a lecturer. Yes, I will start with regression, because that, even if I have people that have never used it, or from social sciences or from natural sciences, is a good way to start the discussion. So for me, yes, it's a good point. Whether it's right or wrong, it's... I thought I had until 5:30. Is that not the case? Really? Anyway, I'm just starting. I'm just starting. Maybe I'll just catch up, and maybe I won't invite so many interactions from the audience. Anyway, so yes. So another term that sometimes gets mentioned is big data, right? And I'm sure some of you are big fans of big data. But sometimes it's a bit of a, is it really the same? And for me, it's not big. It's a comparative adjective. So you have to be big compared to something. You cannot just be big. So if I were a small owner of a corner shop and I've got my spreadsheets in a bit of a tangle, that may already be big data for me. So I cannot deal with it. But yeah, there is some working definitions for this. Typically, it's data that does not fit in memory. And that's not fair, sorry. But But then that can be overcome because then you can add some more memory to your clusters, and then it's not that much bigger, right? Or it's data that does not fit in the machine. But a lot of the times, and I'm just speaking by experience, most of the projects that I end up doing are not big data. They don't have that amount of information to be using this. It's more patterns on data, medium data, if you want to call it that way, but it's not necessary to end up with in those terms. Again, I was talking to you about what the definition for data scientists. There are many definitions, but this is one that I like from Hilary Mason. So she is a data scientist in the US. She's got some background helping the US government as well with policy in data science. And then she tells us this, right? Data science is the combination of analytics and development of new algorithms. And some of us would love to do that. But some of us don't have to invent new things, right? You may have to invent something. If you need to, that's okay. But if you can answer a question simply by counting, you are already helping to move things up. The key thing for her is the effort to ask pertinent questions. And that's far more useful than getting into tangles about whether regression is machine learning or not. Does it help what you're doing? And I told you this was a practical view, so you may hate me forever for telling you not to use all the stuff first, but there you go. So one of the questions that I posed at the beginning was, what would you do? What would you like to know or do if you could get access to all the transactional data in your business? Anyone with some megalomaniac thoughts? Okay, not megalomaniac, but What would you do? What sort of industries are you interested in working on? No? Yes?
I'd want to know exactly what someone wanted, exactly at the time that they wanted it.
Yeah, that's a good point. And what I was going with this is that sometimes we just think, data science is greedy by that, right? So we want more data. But sometimes we need to stop and think, well, we want more data for what reason, right? And what it is that we want to do with it. We need to start asking about the where and the what to do with it and the who's interested in that. And those questions are not generic, right? They have to be quite specific to the industry that you're working on. Someone in insurance would have very different viewpoints from someone that does retailing, right? The questions that you're asking about your data would necessarily be different. Some of the techniques may be similar, but the technique to get you to the answer is not the important thing, is getting you to the answer, right? And just to mention some use cases, if you are interested in customer retention, the type of data that you would be interested in would be very different from those to do product recommendation, right? So a lot of these things, I would like to know what other people like you have bought, and therefore, understand you more as a client in terms of your preferences, so that I can give you something of use, and therefore the data that I use is different from someone that is interested to say, well, I have a relationship with a customer, and I'm interested in keeping them in my books, right? What sort of offers or what sort of usage of my product they have been given, so that I can keep providing that good service. And I'm sure that you can think of your own examples on these things, right? So just some considerations in that point of view, right? So some of us may have arrived here via Uber. And in their case, well, it's the world's largest taxi company, but they have no cars, right? So I'm sure that URL in Facebook is the world's most popular media content. Whether they use it appropriately or not, that's a different question. But, they create no content themselves. Alibaba, the world's most valuable retainer, but they own no stores. Airbnb, the same, largest accommodation provider, but they own no state. And you may have your own ideas, right? So you may be the world's largest, put your logo there, use your data appropriately. But you should start with the questions, not just with the fact that you have some data for X, right? So another question for you. What's the most important skill for you? Programming, business, maths, stats, communications, or any other? No?
It's three of, isn't it?
It's
Drew Conway will say you need hacking skills, you need business domain skills, and you need maths, stats.
yeah, but the most important for you. I'm not asking about what someone else told you about.
For me, it's maths,
For you, it's maths. Yeah. Anyone else? Nothing? The problem is that we start going to this, right? So, yes, after big data solves all of our problems, and we have that, we start flying in magic unicorns. Why is that? Well, because people that start writing job descriptions start wanting someone that has a lot of curiosity and is driven by that, asking questions out of their data. It's curiosity foremost, and all the things come with that. But I also want someone that is scientifically rigorous and has the questions, but knows also how to answer these things with the mind of a chemist or a physicist. And not only that, I would like them to be the most prolific speaker and writer out there, and can outdo everyone else telling us about the insights that they have found. And not only that, they should be able to do this in the most appropriate and professional way for business, right? And the reality is that sometimes we end up going like this, right? So you may remember the England team riding unicorns. They sort of almost get it there, but then they failed, right? And the problem with some of that is that we end up hunting for unicorns. And yes, they tell us that you should have skills like programming on the one hand, and maths and stats skills, and the expertise of things, and all that will give you data support and traditional research, and right in the middle of it, you have data science, and that's the sort of person you should become. But the reality is that maybe some of us are more towards here, some of us more towards there, and a true person that knows all those things is quite difficult to find. And not only that, they want to know how to communicate, how to be curious, how to have rigor, right? So basically, oops, I don't know what happened there. Basically, they just want this, right? And this is quite good because, it's not a being from a different planet. It's a human being with no superpowers, but lots of gadgets, right? So, and kapow, you can destroy the evil. The reality is that sometimes we all actually end up looking like this, right? We're all the same looking, we all arrive with the same outfit, and we just think, oh, we're all data scientists, right? So, cool, right? And that sometimes is a bit of a problem. So, there comes my allegory of the jackalope. So people keep on talking proudly about getting hold of a unicorn for their teams. And my recommendation, as it were, is that you probably shouldn't, look for that. That's impossible to get. And if you find it's going to be super, super expensive, and probably they're, going to be there for a year at most, and then just fly with their fantastic wings and their horn, right? What I suggest is that you could be more realistic and become a jackalope data scientist. It's also a mythical beast, and they don't exist in real life, but they look cute. It's a jackrabbit with antelope horns. Douglas Herrick in the 1930s popularized them. He actually took a jackrabbit, took some antlers, put them together, and then say, "Ooh, I found this animal in the wild." And if you go to the U.S. in Wyoming, you will find loads of places with trophies with jackalopes around there. It's mythical, but it has a bit of a hint of reality, and that's important for me because I would like to get data scientists that are real, that are doing work, rather than unicorns. And yes, it's a hint of reality because there is a virus that attacks the poor rabbits that make them grow horn-like structures in their head. So I'm more likely to find a jackalope-looking beast out in the wild than a unicorn. So there you go. Right. How long do I have? Are you sure? I will try to go fast. Anyway, so talking about valuing data, I'm sure that you would have seen these sort of things. Of course, we're starting with a question. The idea is to start with the business understanding, what it is that I'm required to do, get some data understanding, and probably this part of the workflow is the one that takes the longest, right? So they say that 80% of the time a data scientist would be spending is on data cleaning. The other 20% is complaining about data cleaning. Never mind. We have to do the data preparation, and notice that here there are some loops in these things. the amount of times that I have been given data and I don't know what they mean because they have given me something that hasn't been encoded, that has 1, 2, and 3 with a field name that is called something generic. I don't know what it is. I don't know what 1, 2, and 3 are. Unless it's a Kaggle competition, I would go back to the business understanding people say, oh, you know, what does 1, 2, 3 mean? Oh, that means male, female, or undetermined. Ah, okay, now I know that that's gender. You go back, and then you ask all the questions. So without that, you never get to do what you're doing, right? What you're meant to do, that modeling that someone was talking about earlier on. Data preparation is important because certain models that we want to build expect data to be in a particular form, either in a vector form or in a matrix. So therefore, we need to make sure that it's ready for those things so that we can do modeling. But modeling is good on its own right, but we need to know whether their model is good or bad, right? And if it's bad, then we go back to square one. Now, the other thing that is important to realize is that unless you're doing modeling for things that don't change, think physics, for example. So if I want to determine gravity by the data that I have, gravity is not going to react differently to me. So the data that I have and the formulas and the models that I have are good to stay. Okay, yes, you could argue, well, Newton was superposed by Einstein. Okay, fine. But still, right? The difference is that a lot of the applications that we end up using, we end up affecting what our users are doing. So in other words, the fact that I have recommended something to someone would make them think that it's a good recommendation or bad. And then their data has been affected. Therefore, the data that they continue giving to me is now different because the model has been deployed. So it's not just model drifting because of the model itself, it's because the data also changes. The interactions with our clients in that respect make the data change, and therefore, I need to be prepared to go around that cycle, right? Another thing that people are interested in, and I'm sure that you attended a few of the conferences that happened here about interpretation. So we know that a decision tree is easily interpretable. I can give that to a business stakeholder, and they may be able to discern, if this happens, then that. If that happens, then that. But I cannot give them this just like that, right? And yes, there is a lot of efforts about making neural nets understandable, and I'm glad that that's the case, but it is today still the fact that a neural net is less intuitive than a decision tree. So sometimes we need to consider what sort of models we have, and I'm sure that a few of you have seen this from scikit-learn, right? So like a decision tree about what model to use if you have something, right? So you start here. If you have less than 50 samples, well, bad luck, go and get more. If you need to predict a category, use this, use that. So it's a bit simplified, but still we can understand and use this almost as a cheat sheet for what it is that we need to do. Right. So some recommendations that I would like to give you. Just closing the presentation now-ish. So make sure that you have requirements lists for your projects. Understand what it is needed from the model. Is it a prediction or not, and what's the accuracy that you can live with that with. Have the clearest idea on what you want, and consider the technological setup. It's good to start with some of the models. Earlier on, I went to a talk with someone that was talking about some fantastic models that were sequestered into a particular technology that they had, and they were never able to get them out of that setup. They had to go and rewrite some of the models, and that caused some troubles. Dedicate enough communication and mutual understanding between parts, so having good stakeholders that are willing to sit down with you and answer your questions, and vice versa, is important. And having a clear requirement helps with the main ingredient, data. If it's the sort of questions of tell me something that I don't know, you know already that you are in problems. You're in trouble, right? So get a clear idea. So thinking of data as an asset in business is an important thing. For us as data scientists, we should think of data as the raw material for our model. Without that data, our model cannot be built, right? So good quality data is better, but I'm sure that if you have good quality data, then it's not a real model that you want to build. You probably have lots of dirty things and missing data and all the rest of that. So data preparation is almost always necessary. Very rare that it just goes raw like that. And for some of that, sadly, you may not even need machine learning. You just need some good ETLing tools and lots of patience. For the model, yes, start simple. My friend here hated regression, but it's simple enough. If it starts giving me an idea of what to expect from my data, then I can start building up from that, right? Rather than starting with neural nets and then not knowing what I'm going to do with it, right? I am a big advocate of starting simple. Tinkering with new techniques is super fun. It's super useful. You can put in your CV, all the rest of that. But sometimes, my friends, our clients need answers and they need them yesterday rather than, well, if you give me another 3 weeks, I would improve the accuracy by another 0.005%. And you just go, you know what, go do Kaggle competitions. I need an answer now, right? So as a manager, sometimes I find that one of the most difficult tasks to ask of my team. On the one hand, I understand that it's fun, and I understand that there is a need to push some of the models that we have, but I have to make them understand that we are building these for clients, for an outcome, and you're getting paid for doing that. And sometimes that's not an easy message to give. Earlier on, one of the other speakers, Thomas Cronin, was talking about reasons for data scientists leaving their jobs, and a lot of that comes down to this. People think that they're going to come to a place and they're going to build new models, and the reality is that most of the time they're going to be ETLing, right? So extracting, transforming, and loading data. So it is an asymptotic chase. At some point your data is going to just be there. In terms of production, so production-ready model is good. You need to integrate it with existing setup. But one thing that I suggest that you do is think of the coupling that. Because the moment that your setup changes, so for example, people decide to migrate from Azure to AWS, and you have built it embedded with that, you're going to have troubles. It's not just a plug and play. So think of ways of decoupling your models so that they can be deployed in different settings. Updating the model is important, as we talked about, so retraining the model is important. Bake that into your maintenance for the model as well. Both things, the decoupling and the retraining, is not mandatory, but it all depends on what it is that you need to do. Another thing that has changed in the last, certainly in the last year, is GDPR. I'm sure that you all have heard about it. This slide I presented last year in this very conference before GDPR existed, and probably 3/4 of the audience did not know about GDPR. It's important. It's applicable as of 2018, May 25th. It's of international reach, although it's European, so bear that in mind. And some of the penalties for it are quite hefty. And I would assume that the majority of you, if not 100% of you, already know about GDPR, right? Yes, yes. And if not, you got these sort of things, right? Oh, stay with us, update your contact options. I love this one. It even says, hi, test first name. That's not machine learning, right? That just didn't work, right? Let's keep in touch, mailer, and your inboxes may have looked like this, right? Sound familiar? Yes. To the point that some companies on 25th of May were not even ready. And you would end up with situations like this. If you visited the LA Times, the Daily News, or Chicago Tribune, and I'm sure other ones, here in Europe, you would get these notifications. You cannot access our data because we're not ready yet. Scary or what? So now they have lost some people, right? Because you cannot read that. I'm proud to have tweeted that on the day of 25th of May. I was just going, yeah, good GDPR, good day, excellent. Right, so let's have a look. Let's talk about some challenges and opportunities just to close here. If you're not a data scientist yet, but you are here because you are interested in moving into the data science job, well, you could do this, right? So the machine, there was even a talk that said that, right? Machine learning while you have coffee. So it's exactly that situation. So you may not count yourself as a data scientist yet, but I'm sure that your organizations already have a lot of data, more data than you can imagine. And maybe they need insights, and even actionable insights. Why not? So is the value from each data source exhausted? Perhaps not. Maybe you can start asking questions about the data that you have. Maybe you have multiple data sources and you need to join them so that you can start getting data. And I can tell you a very clear example of a client of ours that thought that their sales data was not even present in their database. And we believe them because they know their data, right? It turned out that we organized a hackathon and the data was there. They just didn't know it was there because it was encoded. Yay! There you go. Are users aware of any possibilities offered by other techniques that are not necessarily only number type machine learning? So social network analysis, natural language processing, others. So maybe that's your thing with your job. Maybe you are thinking of getting into data science, but you think that you need a bit more practice. So fear not. You have things like Kaggle. I'm sure that you know Kaggle. Anyone? Yes. And how many competitions have you won? Oh, we have a winner there. So, 0. I thought you were going like, yes, all of them. So you can enter seriously for winning prizes and money and all the rest of that and become a Kaggle Grandmaster. If you are not a megalomaniac, and when I asked that question, none of you jumped to put on their hat. So if you're not a megalomaniac, but you want to get some training, Kaggle is a really good source because the questions that they pose are really well thought. It's a bit artificial in the sense that you have to beat a certain score that they have, but it may give you a good training with semi-real data. Right? And in some cases, it's actually quite hard competition. So it's not to say that you enter them and you can win them all. But the other good thing is that the community is quite open to share some of their approaches, some of the code, and you can even join other teams and learn from them if that's what you require. Maybe some of you are coming from startups. Your software development is there. You have something fantastic. It's commoditized. Many not very technical ideas can be sorted out with a good website, but sometimes we need extra oomph. So many new companies differentiate themselves through their use of their data in this way, right? Or some of you may be looking for new jobs. So this is a bit of an old statistics, but by 2012, McKinsey predicted 1.5 million shortage of data scientists. So there you go. The world is your oyster. Maybe you just need to jump into the wagon. And certainly, I have seen a rise in available positions. The only thing that I would say if you are in this position is to read between the lines. Because 5 years ago, 8 years ago, probably there were not that many data scientist roles out there. These days, anything is called data scientist. But in reality, you should read and realize that maybe they want someone that is more machine learning engineer or some more, an analyst or, ask questions out of the people that are interviewing you. So in summary, data science is a product of our time. It's new, but it has a background that goes back to the Greeks, if you go by my history. Being a data scientist requires people and technical skills, that is true, but it's difficult to encompass one that has all of those things. Data scientist is therefore a team sport. Get the cottontail rabbit from one pit, the antelope horns from another one, and make do with a team, not just with one person. And you're required to be rigorous methodologically and approach this within the business context. So, of course, keep an eye on a couple of those books. You can see that that book has the jackalope in the cover. I go into a bit more detail as to what you should have a look at in there. And if you're interested in getting the slides with recursion there, you can visit that website where you can download the slides that I used. I've been changing them, so they may have different look and feel. I'll give you a bit more chance to take pictures of that. Therefore, I thank you a lot for staying with me until 5. I know that you are in dire need of a drink, either water or something stiff here, but I'm here for questions if anyone has any.